Okay, whenever you're ready.
Oh, sure.
Okay. Are you ready? Okay, the next team is team 55. Yes, sir. Yeah, you can.
Okay. Good afternoon, professors, fellow classmates, and everyone. Thanks for stopping by and participating in the presentation of our senior design project. Our project is called Whiteboard Intelligent Programmable Erasing Robot, and we also call it WIPER. And we are team 55, and I'm Zhonghao Wei, and here are my lovely teammates.
I'm Peng Qiu.
I'm Jizai Ma.
I'm Lisa Sun. I'm Yiming Yu.
Okay, about today's agenda, we will guide you through the two versions of WIPER, and starting from the designing initial concept to the designing, experimenting, and prototype building stage. We will cover it all in the main section as well as in the appendix. And following with us, you will explore the two versions of WIPER and as well as the promising business prospect it holds. And finally, we will talk about the future work and the potential applications of WIPER. All right, let's jump into it. So our initial idea comes from our experience in taking a heat transfer class in the new build CDS building. We realized that unexpected time efforts for professors to clean these kind of such large and wide whiteboards. So by also searching online, we realized that BU has a bunch of about 50 whiteboards. And also there is a potential growing market for the whiteboard and also for our products because the annual compound growth rate is 2.9 during the 10 years. So we're aiming to light the burden for professors, lecturers, and the custodial staffs by introducing innovative solutions. Motivated by this, we initiated our project. And here is our problem statement. Lecturers and students are facing a challenge of erasing whiteboard efficiently during and after classes, as erasing process is a time-consuming and disruptive. So automated cleaning system at the CDS building is necessarily required. Let's move on to the customer demands.
Okay, so with the problem statement in mind, we talked to a few of our potential users in CDS Studio, like professor and custodial stuff. We found they're expecting a solution that can clean the whiteboard clearly and thoroughly and quickly, but also need to be safe to use and durable in operation. So with that in mind, we think of some engineering spec to match their demands. For example, like cleanliness index, which ranging from 1 to 5, scoring how light the marker is after cleaning by eraser. And we also have specs like load to weight ratio, which measures the maximum load the robot can hold on whiteboard under its current weight. This is very important for safety because we don't want the robot dropped during operation. So to optimize the engineering specs and to fit our customer demands, we have to carefully choose among all of different options. For example, like eraser material, motor type, adhesion method, and so on. Okay, so with that many options, we did some experiments and research about many different options online. For example, for eraser, we have melamine eraser and export eraser to choose from. Also for magnets, we can choose from permanent magnets and electromagnets. And there are all other options on the market. And so we think about how the option works together and think about these 4 configurations here. And we did tests and experiments on each of the options, and we show the result on these radar charts. So each corner represents one of the engineering specs. And from the result, it's clear to see that the configuration 1 is the optimal choice. So following that configuration, we designed our first prototype, the WIPER V1. And it comes with a manufacturing cost around $178. And it uses a dual layer body. We set up 2 matboards together to increase the strength and stiffness. And it's controlled over Bluetooth, which is really convenient. However, just a few drawbacks of our first design. First, we use magnets that directly contact to the whiteboard. We sometimes create too much friction that the car is hard to move. And we use fixed erasers. Sometimes it causes a problem because it cannot go over the markings that we want to keep instead of erasing. And it's manually controlled, which is not very smart. And we have motors there, which is not pretty stable, because sometimes when they move on the whiteboard, it's not very smooth. And you can see from the picture here, there are many spaces are not used. So we actually can build a more compact robots. And which goes to our next slide.
So with the fresh experiences concluded from the V1, we were able to make the V2, which resolves the majority of limitations from V1 and inherit all the good features of it. The top right of the slide shows the initial conceptual design, and in the middle it is the actual robot. And the cost of this V2 is consists of two portions: the 190, which is the price of the card itself, and there's also the 235, which is the real sense camera. This camera is widely used for research and development purposes, but for the actual commercial model of the robot, a cheaper one with basic graphical capability one can be replaced. Here, these two pictures shows the structural configuration of the WIPER. One of the major features we have built in this system V1 is the capability of lifting up its WIPER tab, or say the eraser. And to do so, the WIPER will be able to selectively erase on the area they want to and travel past the part that it doesn't. And another important precondition to do that is the capability of lifting the floating magnets. As previously mentioned, magnets contacting the whiteboard causes frictions and also scratch on the whiteboard. But the floating magnets, which means that they do not contact whiteboard, will be able to resolve all these issues. The erasers themselves, or the major cleaning component, is the melamine erasers. This one's particularly chosen for having a very decent cleaning efficiency, as well as being very light. This here shows the demonstration of how this eraser lifting mechanism works. As you can see, when it is on the static position, when the eraser was being dropped, the crank arm is being vertical with the entire chassis, so that pass that stress coming from the whiteboard directly onto the chassis. And in this case, there won't be additional torque that is needed to be applied from the servo to maintain this position. And now going to the software section.
Now, WIPER's automation comes into three main components. Our previous mentioned motor PID control with our encoded motors, our TB6.2 motor driver, as well as the onboard IMU. But the path planning and the visual detection is done by our April tags here, and as well as our paired Intel Wilson steps camera to identify the boundaries of the whiteboard and the location of the robot. Furthermore, with the imagery processed and received by the computer, our computer will allow for a user input selectable quadrant area cleaning. And once the user selects one of the four quadrants to clean, we'll perform what is called coverage path planning, which is basically zigzagging through the entire area with the cleanable erasers. Furthermore, we added margin constraints, which is reducing the cleaning area by a bit to for a safety factor measurement to prevent WIPER from falling on the whiteboard. So here's our system diagram. As you can see, once WIPER receives the cleaning quadrant input from the user, for example, in here, quadrant 4, it will plan the path and reach the beginning point of the CPP starting point. During that walking process, WIPER's erasers are raised up and does not engage with the whiteboard, meaning no unwanted cleaning will be done. Once it reaches the CPP point, it will begin the zigzags through as shown here, and with the eraser engaged and cleaning the writings as it goes. This is realized by the two separate controls from the remote control done out with our visualization components and our PC as the calculation component. Once the path is determined, the movement commands will be sent through the Bluetooth module to our onboard Arduino, and the Arduino will process these movement commands and real time send back the status report of WIPER, as shown here. In our customized user interface, not only we could see the status and pose of WIPER, the quadrant selection by the user is achieved with only a click with only a few clicks of buttons. Moreover, the plan path as well as the real-time tracking of WIPER is also shown. That concludes our setup for WIPER. Here to talk more is Yiming.
So with regard to our business prospect, while we are developing the WIPER system, we realize its significant business potential as a marketable product. So we believe with $100,000 initial investment and $800 sales price and some reasonable estimation of the R&D and operational costs, our initial investment payback time would be around 3 years. And by the 5th year, we would potentially gain a 24% annualized return. This is almost 5 times greater than our benchmark of 5% in treasury yield currently. To keep our competitiveness of our product, we are committed to improve its capability. So in the upcoming iteration, we are planning to integrate a cleaning spray on the eraser itself. And also we are planning to integrate an obstacle avoidance algorithm on the robot, which would enable the robot to clean thoroughly on the whiteboard and navigate in complex environments. In terms of the prospective industrial application, with some modification, we believe our entire system could be adapted to ship hole cleaning because since they both sharing a similar feature, a magnetic surface. So let's check out our quick video demonstration of our robot. It's gonna illustrate how our system is being set up and how the cleaning process is like.
Okay. Sorry, this.
Thank you everyone for listening. That concludes our presentation for today. We would like to give a special thanks to our advisor, Professor Dubala here, and our lovely EPIC staff for giving us guidance on the manufacturing process throughout the academic year. Thank you. We're open to questions now. So how do you put a load on the wafer? Applying the load, I didn't do it that way.
So you're seeing how much force applied?
Sure, how is it?
Yeah, so the load applied to the wiper is using the servo motor, and it just basically press when the crank arm is going down, and then the entire the eraser is touching the whiteboard, and it's locked at a position so that it maintains that force. And the force it shows
While you're looking for that, I just show for
Well, that would be
Is it a
for,
driving mode one?
ISU and PID control.
I think this one. The Chapman.
Control Wiper, and the visualization also keeps track and tells Wiper to stop if it's out of the boundary.
So this one, so the pressures and how you hold on the whiteboard is because of we have the magnets and produce a force, attraction force to attach to hold the entire system onto the whiteboard, including the pressure exerted on the eraser.
Does that answer?
So as a mechanically, it's doing great. So you guys really nailed it. There's a classic STEM project where a robot follows a line. It's just an optical thing. Have you ever thought of another one where it just uses bumpers and they're just randomly going all over the board looking for lines until it's done, and then you wouldn't need, I understand you use the camera to demo this, but it would seem to me that a kind of dumb system just sits there until I don't see lines. And is that
So while we're conducting interview with the prospective customers, and they indicated they want something could manually select it using graphical user interface. So they could select one quadrant instead of second quadrant, so they could select the claim in one area, not other area. That's one of the customer demanding.
who's the customer?
And as it turns.
Yeah, just imagine the scene. Sometimes professor will leave all the equations and function on the one part, and the other part is just do some calculation and demo. So we want to keep one part like to be unerased and erase another part. So that's why we did this function.
We can do a light demo. That's one.
Yeah, so just to go on Professor's question, I was thinking, so Zumba, it like maps out the area and then it realizes that there's this portion that needs to be cleaned. Is that something you guys would be thinking of in the future? Maybe having it instead of a camera, they raise the able to map out the board and then realize that it's in a certain portion and you know, sort of apply that.
Yes, so modern cleaning system often use what's called SLAM. In our terms, there are LiDAR SLAM and optical SLAM. As we realized, SLAM would not really work with a 2D surface, as the writings are not sticking out from the thing. So mapping would be more easily realized as an optical solution that projects the image into the camera.
So how big of a whiteboard can you potentially think of this? Because I'm sure there's a point where you cannot actually visualize the able tags anymore. You cannot ascertain what shape it is. And also, is there any issue with the lens distortion, or do you know?
Yeah, so actually we haven't tested the maximum size of the whiteboard, but I think theoretically you can claim like even the board like this big, because so we can the text you see over there is pretty small, but we can print out the larger text and they can detect from a really far like range. And then you mentioned like so and then the camera, it has resolution limits. So but we tested like even this, like you can see those tags even from like 50 meters. So I think it's pretty useful for larger whiteboards. Yeah.
In terms of the distortion, this camera solves the problem. It has inbuilt algorithm to solve the distortion part. So it adjusts itself automatically.
Yeah.
Make it go.
Absolutely.
Normally the camera would be mounted like.
Yeah.
So
The setup part is the Bluetooth can take a little bit depending on the
Sorry,
situation.
every example is like.
Yes.
Yeah, all been there.
So while you're doing this class, did you guys run into issues with like, some markers, especially if it's on the whiteboard much longer? reflection. So
Yes,
you-
so as we mentioned in the future item, we realized for markers that are left for more than a week, they become very hard to clean. And this, the implication of the future items of the cleaning spray, expo cleaning spray, it could really resolve that issue. As of right now, it cleans this quadrant, so it splits the entire area into four. If it's in one of the quadrants, it would be.
So if that screening line came down to this quadrant two, it would be so.
It would only additional.
You guys. Yeah.
Can you remind me again why it's on the camera instead of the landmarks that you put on the like where it's up?
Yes, so the visualization process is very future-proof. So in one of our original design specs, we also planned for specific cleaning. So the professor can use the mouse or use the screen to draw an area, a circle, and WIPER would clean this in that circle. But if we were to use tags, the accuracy as well as seeing what is needed to clean is
All right, it's ready to go.
Just running because we are short on time.
Okay, sorry. So right now, the erasers are not engaged. It wouldn't erase anything else. But once it reaches the area, the erasers are put down and it begins cleaning.